Welcome to the Unit 2 mock exam for GCSE Foundation Level Maths. The paper I gave you was for November 2015 and is the most current paper available. Some of you will have noticed that the front page is slightly different from the past papers that we've done up to now, in so much as AQA have changed the format where the candidate's details goes all the way across the page now. On past papers there was a marking schedule down here for examiners to put the marks from each of the questions. That's been removed. Please don't let this throw you when you're taking your exam. It's just a change of the format of the front page. It's a foundation tier and Unit 2 covers numbers and algebra. And what we'll do now is quickly check some of the instructions and information. For those of you who want to go straight to particular questions to check their papers, then I've provided YouTube shortcuts either side of this front page in the light blue areas. Okay, so what does the paper tell us? Well, it's a 1 hour 15-minute paper and there are 66 marks available. So it's roughly a mark a minute, giving you 5 to 10 minutes to check your paper at the end. The most important thing for Unit 2 is the fact that you can't use a calculator in this paper, which probably makes it the most difficult of the 3 papers. Please remember that mathematical instruments need to be taken, so rulers, protractors, compass and all the rest of it. It's just to be on the safe side. On the instructions, these are pretty standard, where you're expected to write in black ink, except for diagrams which they expect to be in pencils. Answer all the questions, use the space provided, and do all working out in the book. Under information, we have marks shown in brackets, so always look at what a question's worth when you're answering it, and make sure you have enough stages to get that number of marks. As we've already said, there are 66 marks available, and questions 7, 10, 16 and 17 require you to write some answers down in English, so the working out won't suffice. You have to put sentences down to explain your answer, and these are easily identifiable within the paper with an asterisk. You can ask for more paper if you want it. And finally, the most important piece of advice in all 3 units that you take is that you have to show clearly how you work out your answers. Answers themselves are only worth 1 mark. There are far more marks available for showing your working out, and that is the difference between passing and failing this exam. Let's start with question 1A. So question 1, always a nice easy lead into the exam to calm you down, is asking you, can you identify odd numbers and what is the next odd number after 4, 5, 2, 9? So 4, 5 doesn't change, and the next odd number from 29 is 31. Write down all the factors of 21. So writing down our factors, the first factors of 21 or any number is 1 in itself, so 1 and 21. 2 doesn't divide exactly into 21, but 3 does, and here you need to know your times tables. 3 7s are 21. 4 doesn't go into 21, 5 doesn't go into 21, 6 doesn't go into 21, and then we're back at 7. So we've covered all our factors. So our factors for 21 are 1, 3, 7 and 21 itself. Question 1C is asking us to show that 20 is a multiple of 5. So you can do this in 2 ways. You can show that 4 times 5 equals 20, or you can divide 20 by 5 and it gives you exactly 4. So either way will get you the 1 mark. Question 2a. Write in words the number 2.46. So we'll write this in words 2.46. And that's good enough for the marks. Question 2b is asking us to write the number 2046 to the nearest 10. So this is a little bit of rounding. So to the nearest 10 is we're looking at the 4, but to make our decision we look at the next number along, which is the 6, so we round up. So our number becomes 2050 to the nearest 10. Question 2c is asking us to write down the value of the digit 4 in the answer to 246 times 10. So the number we would end up with is 2460. So the value of the number 4 in this new number would be 400. Or you could write hundreds. Question 2d is a BIDMAS question, and it's asking us to work out 2 plus 4 times 6. So BIDMAS tells us to do the multiplication first. That's the D in BIDMAS. So it becomes 4 times 6 is 24, and then you do the addition, which is 2 plus 24 gives us 26. Question 2e. Use each of the numbers in 2, 4 and 6 just once to calculate an answer of 3. So here it's telling us we need to find an answer of 3 using the numbers 2, 4 and 6. And it may require some trial and error. So the way I looked at it was, I know that 4 goes into 12 3 times, so I did 2 times 6 and then divide it by 4. So I've used 2, 4 and 6 just the once, but in this instance, because BIDMAS tells me to work from left to right, I do 2 times 6 first, which gives me 12, and when I divide that by 4, it gives me the 3 that they're looking for. So 2 times 6 divided by 4 equals 3. Question 3a. Circle the decimal that is equivalent to 3/4 and should be able to do this through recognition that 3/4 is 0.75. Question 3b is asking us to circle the percentage that is equivalent to 0.3. Well, 0.3 is 3/10, and when I make it equivalent, it becomes 30 over 100, and 30 over 100 is 30%, so 0.3 as a percentage is 30%. Question 3c. 3 of these fractions are equivalent to 3/4. Circle the fraction that is not equivalent, and they've stressed not. So all we need to do is see if they are equivalent. So if we start with 3/4, to get 6 as our numerator, we've multiplied it by 2. So if we multiply the denominator by 2, we get 6 over 8. So it is equivalent. And if we go along the line and do this equivalence for each of our fractions, we can find out which one is not equivalent. So to get our 9 on the top, we've multiplied it by 3. And when we multiply 4 by 3, we get 12. So again, it is equivalent. Moving on to the next one, if I multiply the 3 by 4 to get my 12, then I need to multiply my 4 by 4, and I get 16. so this one is not equivalent. And just to check the last one, if I multiply my 3 by 5, I get 15. I multiply 4 by 5, I get 20. So that is equivalent. So the one that is not equivalent is 12 over 15. Question 4a is about sequences. So here is a linear sequence. The first term is missing. Work out the first term. So as we look at our sequence, we can see that our rule is we go down in eights. We're taking away 8 every time. So to get from 13 to this number, we take 8 away from 13 and we get 5. Now some of you have got into the bad habit of leaving the number 5 there. You have to put the answer on the answer line. So when they give you these dotted lines here on the question, please don't forget to fill in the answer here. Question 4b, and here is a different linear sequence. Work out the next two terms. So we're adding 6 as our rule, and we can check this as we go along. Plus 17 plus 6 is 23, plus 6 is 29, plus 6 would be 35, and then 41. Now again, don't leave the answers there, put them on the answer line. So the two answers we need for our marks are 35 and 41. Question 4c is asking us to work out the expression in the nth term of the sequence from 11 to 17, 17 to 23. So our rule is plus 6. We're adding 6 between each of the terms. So that gives us 6n. And then what we need to do is an adjustment to get from 6 to 11. So we need to add 5 to get our first term adjustment. So our answer is 6n plus 5. Question 5 is giving us 6 numbers that we need to put into the circles where the product of the 3 numbers on each side is 48. So it's almost like one of these games you get in the newspapers. So you can only use the numbers once and they have to go in the circles to give us the product. Now, this is one of our buzzwords that we've done since week 1, that if you don't know the meaning of the word product, you can't answer the question and you will lose 3 marks. So those of you familiar with the word product will know, for example, that if I have 2 times 4, the product is 8, and that's what product means. Now to address this question, I would start with the big numbers and say that they really need to be your starting point. So 12, 8 and 6 in order to make this number of 48. Now I know 12 goes into 48 4 times, so the only way I can make 4 with the remaining numbers with my number 12 is 1 and 4. So I believe 3 of the numbers I need are 1, 12 and 4. Now 8 goes into 48 6 times, so the only way I can make 48 up is 1, 8 and 6. And that leaves the number 2, which we haven't used yet, so I need to use 2. So 2 6s are 12, and 12 goes into 48 4 times. So now I know my sets of numbers that give me the product of 48, and I've used each number. I need to place them in the triangle where they're going to be used. So the number 1 is used in 2 of my calculations. So 1 needs to go at the end. Now 12 only appears once, so I can put 12 here. And 4 again appears twice, so 4 goes here. Now I've used 1 before, here. So 8 only appears once, so it goes in the centre. and 6 appears twice. So 6 is again on a corner. And with 6 and 4, 2 only appears once, so 2 goes in there. So for my solution, my triangle would look something like that, where when I multiply any of my lines, 6 times 8 times 1 gives me 48. 1 times 12 times 4 gives me 48. And then 4 times 2 times 6 again gives me 48 as a product. Question 6 is a fraction of an amount, and they're asking us to work out 3/5 of 45. So in our class I showed you the technique for doing this by not doing that first, but by doing this first. Because when you do this, generally the answer you'll get will be a nice round one. So 45 divided by 5 gives us 9. So it leaves us with 3 times 9, which is 27. So 27 goes on your answer line. Question 6b is asking us to multiply two fractions. So the technique for doing this is multiply the top by the top and the bottom by the bottom. So 1 times 1 is 1, and 5 times 3 is 15. So our answer is 1/15. Question 7 is telling us that there's a company which has 8 minibuses, and each minibus carries 14 passengers. The company wants to take 98 people on a trip. Do they have enough minibuses? You must show your working out. And also, they want the answer in words. So, the way to prove this is simply multiply the 14 seats per minibus by the 8 minibuses we have. So a bit of multiplication. 8 times 4 is 32, and 8 times 1 is 8, plus the 3 is 112. So they have a total of 112 seats. Now your answer needs to put in some words. So, yes, they have 112 seats available and only need 98. So something along those lines to show that you've put words into your answer. Question 8 says that Pat works 38 hours a week. She works 28 hours Monday to Friday and then 10 hours on a Saturday. Her normal pay is £7 per hour. However, on a Saturday, her pay increases by 20%. Work out her total pay. And there are 4 marks available. So a few stages of working out that we need to show. Let's start with her Monday to Friday pay. So 28 hours multiplied by our £7 an hour is 7 eighths of 56. 7 times 2 is 14, plus the 5 is 19. So she earns £196 for her Monday to Friday hours. Now let's look at her Saturday hours. She has 10 hours at £7 an hour, gives us £70. But we need to add 20%. Now here we use our 10% rule. So 10% would give her £7, so we multiply it by 2 to get £14, which gives us our 20% for her extra. So we need to add £14 to her 70 to get £84 for her Saturday work. Now a simple piece of addition where we add 196 to the 84 to get 108 £280. So her weekly wage is £280. Question 9 is asking us to order some decimals. Now, one of the easiest ways we discovered in class to do this was to make them all look the same. So 0.7 is the same as 0.700, and 0.81 is 0.810. But by doing it this way, you're actually just comparing the numbers. So 0.684 now looks like the smallest number, then 0.7, and then finally our biggest number, 0.81. Question 9b is asking us to multiply some decimals. So we need to use our rule for multiplying decimals. In other words, move your decimal points out the way. So we've moved them 2 decimal places, 1 for each number. And then we do 3 times 2 gives us 6. Now we need to put our 2 decimal places back. So I have 6 and move it 1, 2 decimal places. So my decimal point is here. So my answer would be 0.06. Question 9c. Work out 0.6 minus 0.37. So this is seeing if you can do the column method with decimals. So all we need to do is 0.6 and 0.37. And there's an invisible 0 here for our 6. So 7 from 0 doesn't go, so we borrow 1 from there and carry it across. 7 from 10 is 3, 3 from 5 is 2, and then put in your decimal place. So our answer on our answer line is 0.23. Question 10 is stating that the cost of a taxi ride is given by the formula C equals 4.5 plus 0.5 m, where C is the cost and m is the number of miles. And question 10a is asking us to work out the cost for 18 miles. And again, it's got our little asterisk, so we're going to have to put some words into our answer. So let's work out the cost. So the cost is 4.5 plus, and now we have to put in our 18 for our miles. That's what m stands for. So 0.5 times 18. So when you're multiplying a number by 0.5 or a half, you end up with 4.5 plus, so 0.5 times 18 gives us 9, because it's a half of 18, that's what it's saying. So when we add these together, we end up with 13.5 as our answer. Now in money, don't forget to put your 0 there, because it's expecting £13.50. Okay? And don't forget we need some words as well. So put anything down, because they've got the asterisk. £13.50 is the fare for the journey. Anything like that will do. Question 10b is stating that Sidra paid £17.50 for her taxi ride. How many miles did she travel? So now we need to substitute the cost C into our equation and solve it, and let's have a look at what we get. So we have £17.50 is equal to 4.5 plus 0.5 m. Now straight away you should recognise this as a two-step equation. So step 1, we take away the 4.5 from both sides. When we do that, we end up with £13 on this side and 0.5 m on this side. do the opposite, so we need to divide both sides by 0.5 to leave our miles on its own, and 13 divided by a half essentially is another way of saying double it, because 0.5 is a half, so it becomes 26. So Sidra travelled 26 miles. Question 11. Tom took 3 tests. Here are the results for English, Maths and Science. Write his results in percentages. So this is a way of getting you to change various formats into percentages. The way I would address this is we know the numbers 20, 50 and 200 are associated with 100, which is what we need for percentages. So let's look at the first one where it's 13 over 20. Now to get a percentage, it's something over 100, so we can use equivalents. I've multiplied it by 5. So if I do the same to the top, I end up with 65. So Tom's mark for English is 65%. Let's look at maths. 37 over 50, to become a percentage, is something over 100. So all I really need to do is multiply both the numerator and the denominator by 2. And I end up with 74%. So in maths, Tom gets 74%. Finally, science, again we can use equivalents, because I've got 125 over 200, which if I divide it by 2, it gives me my 100 again. So what I need to do is divide 125 by 2, which we can use long division for. So 2 goes into 12 6 times, 2 goes into 5 twice, remainder 1. 2 goes into 10 5 times. So 62.5 over 100, which gives him 62.5% for science. Question 12. Ruth left her office at 2 o'clock in the afternoon. She drove to 2 meetings and then drove home. The distance time graph shows her journey. So we're going to switch between this graph and our questions. Let's have a look at the first question for question 12. How many minutes did she stop altogether? So this is checking that we can read the time scale across the bottom. So stopping is the horizontal lines that we have on our speed distance time graph. What you need to look at is we have 1 hour gap split into 3 groups. So 1 hour is 60 minutes. When we divide it by 3, it tells us that each minor marking is 20 minutes. So here she stopped for 20, 40, 60, 80, 100 minutes. The question is asking for minutes, so we can put 100 minutes on our answer line. Question 12b is asking how many miles did she drive altogether. So going back to our graph, it's asking us to check our mileage on the y-axis. Now if she starts from the office here and drives to here, that's her mileage outbound. So we need to know our scale. So we have a gap of 10 divided into 2 parts, so each part is worth 5. So here she's gone 55 miles outbound. So she's done 55 miles out. And then if we take each of these smaller divisions as a 5, she's done 5, 10, 15, 20, 25, 30 back, and she hasn't quite made it back to the office. So in total she's driven 85 miles. Question 12c is asking us on which part of the journey was her speed the fastest. So back to our graph, we're looking for the steepest line on our graph. Now looking at it straight away, I can see over 40 minutes she's done 5, 10, 15, 20, 25, 30, 35, 40 marks. So A looks quite promising. So that's 1, 2, 3, 4, 5, 6, 7, 8 squares while she's doing 2 across. So C is not as steep. E definitely isn't as steep. And in 2 across on F, she's only gone 1, 2, 3, 4, 5. So the steepest part of our speed distance time graph is A. Back to the answer, and we circle A. Question 13 is about bags of marbles, where M is the number of marbles in bag A, B has 6 more marbles than bag A, and C has twice as many marbles as bag B. And question 13a is asking us to write an expression for the number of marbles in bag C. So if there are M marbles in A, then bag B has M plus 6. And then bag C doubles that, so it's 2 lots of M plus 6. So the answer they're looking for the expression is 2 lots of M plus 6. Question 13b is saying there are 66 marbles altogether. Work out the number of marbles in bag A. Now what you need to do here is realise that all of these 3 bags equals 66. So I need to add the 3 bags together. Okay, so the only tricky bit is bag C, where we need to open the brackets to work out what we're looking at. So let's tidy it up a bit. We've got M in bag A plus M plus 6 in bag B, and in bag C I need to open my brackets to see how many M's and numbers that I have. So when I multiply 2 by M, I end up with 2M, and when I end up multiplying 2 by 6, I end up with 12. And this is all equal to 66. Now what I need to do is go along the line and simplify it all. So I have an M, another M, plus another 2 M's. So I have 4 M's. Then go along and add your numbers. So I've got a plus 6 and a plus 12, so I plus 18. And this is equal to 66. Now this should now look familiar, where with a 2-step equation I can get M on its own. So let's do step 1. Take away 18 on both sides, and you end up with 4M on the left and 48 on the right. So to get M on its own, I do the opposite, so I divide both sides by 4, and it tells me that M is equal to 12. So the number of balls in bag A, which is just M on its own, is 12. Question 14 is giving us 5 expressions that when you add the expressions together, you get an answer of 6x. Which 2 expressions can we do? So the first thing to discount is if we add A and C, because they're the simplest ones, with just 2x and 3x, we'd only end up with 5x. So it can't be A and C. That also discounts A and C from any of our other answers, because all of the others have an x squared in them, which need to be cancelled out. So straight away, we can discount A and C. So what we need is something that negates an x squared. So the only way to get rid of an x squared is with a minus x squared. So our answer has to involve D. Because when we have an x squared, and we take away an x squared, which is what we have here, they cancel each other out to leave us with just an x term. So all we need to do now is look at what number added with 2 gives me the 6. Well, 3 doesn't, so that leaves the plus 4 there. So the two expressions I'm interested in are B and D. Question 15 is a formula n equals 2a plus b. It's telling us that a is a 2-digit square number and b is a 2-digit cubed number. What is the smallest possible value of n? And this is worth 3 marks. So let's have a look then. A 2-digit square numbers. So my square numbers are, well, 1 squared is 1, 2 2s are 4, 3 3s are 9, 4 4s are 16. So the first 2-digit square number that I come to is the number 16. So for A is equal to 16. Let's look at B. B is a 2-digit cube number. So we're looking for the smallest possible value. So let's look at our cube numbers. Well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So the first 2-digit cube number we come to, so our value of B, is 27. Now we need to put them into our formula to calculate our value of n. So n becomes equal to 2 lots of 16 plus 27. And of course we do the 2 lots of 16 first. So 32 plus 27 gives us 59. So our value for n is 59. Question 16 has an asterisk, so it's expecting some written answer. And it's asking us about the two offers, offer A and offer B, for packs of batteries, where Zach wants to buy 40 batteries and he's going to go for the cheapest offer. And there are 5 marks available. So a lot of marks on offer here, so make sure you're working out. Don't just have a guess at one of the 2 answers, because that's only worth 1 mark. So let's do offer A first. So let's have a look at offer A. And basically a pack of 4 at £2.52 is a third off. So he would require 40 batteries divided by 4 is 10 packs of batteries. So 10 packs of batteries times our £2.52 will give us £25.20. However, there is 1/3 off. So here we need to divide £25.20 by 3 to get 1/3 of our amount. 3 doesn't go into 2, carry the 2. 3 goes into 25 8 times, which is 24, remainder 1. 3 goes into 12 4 times, and carry the 0. So we need to take off £8.40 from our £25.20. So let's do that. So when I take £8.40 away from £25.20, I end up with £16.80 for the price of my batteries if I got them with offer A. Now let's have a look at offer B, where we have 5 batteries per pack at £2.75, and if we pay for 3 packs we get 1 free. So we need 40 batteries still, and we divide it by 5. So I need 8 packs. Now with our offer of 3 packs plus 1, giving us 4, I need 2 lots of this to get my 8 packs. So I'm going to end up buying 6 packs at the offer price and getting 2 packs free. So I need to work out 2.75 times 6 to work out the cost for offer B. So let's do that. 275, and we've removed 2 decimal places because we've gone and done that, and we can do the multiplication now. So 6 5s are 30, 6 7s are 42, plus the 3 is 45, and 6 2s are 12, plus the 4 is 16. And now I need to put my decimal points back. So £2.75 times 6 is £16.50 for offer B. So in my answer line, you have to write down in words, because of the asterisk, your results. Offer B is cheaper by 30 pence at £16.50. Question 17 again has an asterisk, so they're looking for a written answer. Now, here we have 2 function machines where the inputs are equal. The difference between the 2 outputs is always 8, and we have to write something to prove this. So let's put in an input of A, and when I multiply it by 5, I end up with 5A, and then I go along, I end up with 5A minus 2 as my output. Let's do the same for the second function machine. I put in A, I have A minus 2 at the first function, and then I need to multiply it all by 5. So 5 times A minus 2. So my output here is 5A minus 2. And I need to show why there's always a difference of 8. So in my first function machine, I have 5A minus 2. However, for my second function machine, I have 5 multiplying A minus 2 in brackets. So I need to open my brackets to see what's going on. So here, 5 times A is 5A. And 5 times minus 2 is minus 10. So I have 5A minus 2 on one side and 5A minus 10 on the other. So when you start looking at your differences and you subtract the two, 5A minus 5A cancel each other out. And then you end up with minus 2 minus the minus 10. So when you do minus 2 minus minus 10, you end up with positive 8. So for our answer, we have to write something down. When you expand the brackets and cancel each term, there is a difference of 8 between the expressions every time. Okay. And that should suffice. Question 18a is asking us to work out the product of the prime factors of the number 132. So the way to do this is write down 132 as our starting point and ask yourself which two numbers multiply together make 132. So a lot of people spot it's an even number and go for the number 2. So 132 divided by 2 gives us 66. Then, when we look at the prime factors of 66, it breaks down into 2 and 33. And now we're looking at 33. You can see that 3 divides into it with 11, which is also a prime number. So the prime factors that make up 132 are 2, 2, 3, and 11. Question 18b is asking us to work out the highest common factor between 110 and 132. Now we've already worked out the factors for 132, so let's do the same for 110 and see which factors they have in common. So we write down 110 and it's divisible by 2, which is one of our factors, and 55. 55 is made up of 5 and 11. They're the prime factors that make up 110. Now, in order to find out the highest common factor, all you need to do is see how many factors are common to both and multiply them together. Let me show you. The number 2 is common to both of our sets of prime factors, and the number 11 is common to both of our prime factors. 5 isn't, and 3 isn't, and we've already covered the 2. So if I multiply 2 by 11, I get 22. And 22 is the highest common factor for 132 and 110. Question 19. It's asking us to use approximations to estimate the value of 3.92 squared and 0.48. So 3.92 is 4 as an estimate, and we need to square it. And 0.48 is roughly 0.5. So when we carry out the maths, 4 squared is 16, and when you divide 16 by a half, in effect you're doubling it. So you should end up with an estimate of 32. The final question, question 20, is a nice straightforward ratio question where we're being asked to divide £5,600 in the ratio of 5 to 3. So this is a totals type ratio question. So we have 5 to 3 and our total is 5,600. So it lives over on the totals side. We have a total of 8 parts, so we need to divide 5,600 by 8. So 8 goes into 56 7 times, and then put your zeros on. So one part is worth £700. So we need to go back to our ratio and multiply each side by our £700. So 7 times 5 is 35, and add your 2 zeros. 3 times 7 is 21, and add your 2 zeros. So £5,600 splits into £3,500 for one set and £2,100 for the other ratio. A way of checking this is make sure when you add them together you get your £5,600. And that's the last question of the exam. So I hope you did well in your Unit 2 mock exam, and that you'll start revising a bit harder between now and your exams in May and June. As always, this was an Archie the Pooch production, and we're wishing you all of the best for the future. Goodbye.